Hello, we're going to continue with Unit 0, studying limits and continuity, and in the next couple lessons we're going to talk about how to simplify the process using basic limit laws and other strategies to find limits without generating tables every time. So we're going to find limits of complicated functions by using basic limit laws. And there are a few basic limit laws here. The first one is the sum law. If the limit of f of x and the limit of g of x exists, you can find the limit of f plus g by just adding their limits together. If you have a constant times a function, you can find the limit of the function and multiply that limit by the constant multiple law. For the product law, if both limits exist, you can multiply the limit of f of x times the limit of g of x and get your limit of f times g. And quotient, if g of x is not equal to 0, you can divide the limit of f of x by the limit of g of x to find the limit of f divided by g. For powers and roots, essentially, if you have a power of a function, you can take the limit of that function and raise that limit to a power. Same thing with the root. This one will make more sense when you see it because we typically don't even write it out that way. So use the basic limit laws to evaluate. This is actually where that power law comes in because we have a power there. So if we find the limit of x as x approaches 2, and just plug in 2, we can take it to a power. Technically what you're doing here is substitution. So 2 to the third power is 8. So the limit as x approaches 2 of x to the third power is 8. Now, the limit as x approaches 2 of this function where you're adding, we're going to do 2 to the third plus 5 times 2 plus 7, and we're going to combine those all together. So 8 plus 10 plus 7 is 25. And then along with the power law, this is a root, which is technically a power. We found x to the third plus 5x plus 7 is 25. So all we really need to do is take the square root of that limit to get 5. If you can, what we're really doing here is direct substitution. The only time that doesn't work is if it is not defined at that point. Okay, so we're going to go ahead and do the next one. The limit as t approaches -1 is -1 plus 6 over 2 times -1 to the 4th power. So we get 5 over 2 for our final answer. And for the last one, I can do 3 to the -1/4 times 3 plus 5 to the 1/3 and simplify that. So 3 to the -1/4, I can't really do anything with that. Right now, I have 8 to the 1/3, which is the same thing as saying the cubed root of 8. So the cubed root of 8 is 2. And anytime you have a negative exponent, you can move that down to the denominator. So my limit here is 2 over 3 to the 1/4 power. One thing I will tell you on the AP exam is you probably could have left this like this for an answer, times 2. And they would have taken it because you don't always have to simplify things. So if you're ever not sure about how to simplify, that works. Example 3, show that the product law cannot be applied for f of x equals x and g of x equals x to the -1 as x approaches 0. So the limit as x approaches 0 of f of x is going to just be 0. If I rewrite this as 1 over 0, the limit as x approaches 0 of g of x, if I have 1 over 0, that does not exist. And to be able to use the product law, we have to have limits that exist for both functions. Since we don't have a limit here that exists, we can't apply it. Okay, that's pretty much all you're doing today. Here's your practice. Have fun. Let me know if you have any questions.